In this video, we're going to look at function composition, and we're going to tie this up with some ideas with curry and uncurry functions in Haskell. So let's try to get an idea here. So first thing, I have a function. I have a function called curry, and curry is a function that is defined as follows. It takes in as an input parameter. It takes in as an input parameter a function that is non-curried, meaning it takes in as an input a function that takes in a tuple of a comma b, some types a and b, which gives you back some value of type c. And what curry does is that it takes in this uncurried function and curries it, meaning the output is going to be a, b, and c. So just to visualize this, think about this function. Think about this function as the uncurried function, and the same function which is uncurried, because why is it uncurried in the first place? It's uncurried in the first place because it expects as an input a tuple of a comma b, meaning it expects both its inputs a and b at the very start. They must be present, right? And what I'm doing here is I'm in some sense converting that function into a curried representation, which is this piece here, which is the curried representation of the function, because now this function over here is simply, by using Haskell's curry notation, is a function that takes in as an input some a, which in turn gives you back a function that goes from a b to a c. So if I give in one parameter, I do get back some function as an output. I do not have to have a and b present at the very start when I call the curried representation of the function. Okay, now what does uncurry do? So I have a complementary function which is uncurry, and the type of uncurry is basically it takes in as an input a function that is already curried, something like this. This a function is already curried, and as an output, what uncurry does, it basically uncurries this function, meaning you get back as an output a function that takes in a tuple, which in turn gives you back some c. So you can think about this piece over here. This piece over here is again our curried function, and you get back as an output something that happens to be the uncurried representation of that function. Okay, so this function that was originally curried, meaning if you give in one parameter of type A, you get back a function that goes from B to a C. This entire function now has been uncurried, where A and B are required as the very first parameter, as a tuple at the very start of this function. Okay, so what would one typical implementation look like for curry and uncurry? So these are the type signatures. So remember, this piece over here is a type signature for curry, and this piece over here is a type signature for uncurry. And if I were to write the implementation for curry basically as an implementation takes in this function. It takes in some function f. It takes in some function f. It then takes in some values a and b there. So it takes in some values x and y. And what it gives you back as an output is just some kind of a c there, right? It gives you back some kind of a c as a final output. So this could be equal to simply as saying f of x comma y. So what I do as part of my implementation is this function f takes in as an input a tuple of some values of type a and b. These values of type a and b is already collected in the variables x and y. So I'm taking my x and y, making them a tuple, and once I've got a tuple, I'm applying that tuple on my function f. Okay, so the type of this curry over here is simply takes in a function f, right? Which in turn gives you back a function. It gives you back a function goes from a to a b to a c. Which in turn, when you apply x on it, gives you a function goes from b to a c, and finally when you apply y on that, it gives you back a value c. So just to make this a little bit clean here, what we're going to do is first thing, let me kind of use a different color there. The type of curry, right, is simply a function, this uncurried function from a tuple from A to B, giving back some value of type C, and curries it to give you back a function that goes from A to B to a C. Okay, that's what curry is. What's the type signature for curry F? The type signature for curry F is basically, because we've already applied this function F, curry F's type signature is it goes from an A to a B to a C. It's a function. This is a function that expects a value of type A. It expects then internal value of type B, giving back some value of type C. What is the type signature of curry F of X? The type signature of curry F of X in this case is because you've already applied this X there. Okay, now you can think about by using currying there. This is completely equivalent to saying something like that. So type signature for curry F of X is basically a function that goes from B to C, and finally the type signature for curry F X Y is simply C. Okay, and we can do the same thing. We can do the same thing for UnCurry now. So UnCurry can be written as UnCurry takes in as an input some function f. It then takes in some tuple. It takes in some tuple of x comma y, and finally, as an output, it gives you some value of type c, and that c is basically using that function f, applying a and b. So in this case, x and y. Remember, these a and b's are my type variables, and those values are stored in my variables x and y here. So this is x and y. Okay, so let's put the type signatures here. So the type signature for UnCurry, just UnCurry by itself, has a type signature that goes from A to B to C. That's the function. It gives you back the uncurried representation of that function, which is this piece. This is the type signature for UnCurry. Likewise, UnCurry F. The type signature for UnCurry F, because F is this parameter. This is what F is. F has already been applied, so the type signature is going to be basically the function, which is the uncurried representation. Okay, and that makes sense because uncurried takes in this function f and gives you back, it spits out some value that happens to be a function, which is basically the uncurried representation. And likewise, the type signature for uncurry f, and now if I apply in the next parameter, which is my tuple there, is basically where this entire piece gets applied. The type signature for this piece is just C. Okay. In the next video, we're just going to look at one more example on function composition, where we're just going to uncurry function composition with UnCurry.